Now, again, hopefully everybody has their calculator. All right, let's take a look now. All right, number 20. All right, I'm going to let you read it to me. Read it. Yes. You know how to do this? No, definitely not. You don't multiply to find perimeter. Who can tell me how to find perimeter? What do I do to find perimeter? You add all the sides. Now, the first thing I want you to do, though, is because this requires some thought. Hey, you're going to have to draw a picture. All right, I want everybody to draw a picture of a rectangle. Now, once you draw your rectangle, all right, now we're going to put in the two smaller sides are what? It says here 5 2/3 and 5 2/3. I am missing, come on, I need you to concentrate. I'm missing these two sides. All right? No. Nope. 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 Carter, tell me. Good. And then? You would do that, and then you would do 23 minus. Yay. Very, very, very good. Listen to what he says. All right, so hold up. You're exactly right. I'm going to let you finish me off. That was very good. Listen, guys. Does everybody understand we're missing this piece of the puzzle right here? Everybody see this, right? Come on, everybody got to listen. It's not area. We're adding things up. So I need everybody on their calculator to do 5 2/3. Now, how many 5 2/3 are there? So you could multiply 5 2/3 by 2. All right, or you could do 5 2/3 plus 5 2/3. When you add those together, you get 11 1/3. So those, hold up. When you add those together, you get 11 1/3. Now, that's that total length. But the total perimeter was 23 1/2. So now you want to subtract 11 1/3 from 23 1/2. All right, Carter, are you with me? So what did you get when you did 23 1/2 minus 11 1/3? Shh, shh. Is that right?
No, I got 12 1/6.
All right. I know 12 1/6. I know, I got you. I understand what you were saying, but you're not with me now. I want you to stay with me. I asked you to do 23 1/2 minus 11 1/3. That's what I asked you. All right, Carter, I know what you're doing, buddy. You hear me? Don't worry about it. All right, don't worry. I'm trying to get you guys this year to stay with me. Think with me. All right, some of you guys are on your own. I don't like that. All right, you need to learn to concentrate on what I'm saying so I can show you. All right, now that 12 1/6, Carter, represents what? What does that 12 1/6 represent? Both sides. The 12 1/6, hold on to your question for a second, I see it. That represents that missing side, but it just doesn't represent one of the sides, it represents what? Both of the sides. That's why now what do you have to do, Carter? Divide by 2. Then you take 12 1/6 and you divide it by 2. And tell me what that is. Let Carter answer, please. I'm listening. What? 6 in. Is that right, guys? 6 in 1/12. Thank you. 6 in 1/12. Now look, guys, hear what I'm saying. All right? Now, I'm not saying that was simple. I'm saying you should be able to see that. That's what I'm saying. I don't want you trying to memorize a bunch of rules. I want you saying, hey, the perimeter is all the way around. They gave me two sides, so I add them up and subtract. Go. Very good question. So listen to me now. If I did this, here's what I want to show you now. I want everybody to look up. Or I'm really trying to make it make sense for you. So this right here, that right there represents the perimeter of the rectangle. Are you with me? So what I'm trying to get you to visualize is that if I cut it right there and lay it and draw it around, it would lay out all the way like that. Do you agree? So in other words, there's this side, then there's a shorter side, then there is a longer side, and then there is that shorter side again. Now this over here, I didn't do a very good job on this, so I'm going to erase this so you can see it better. So look. Now that represents the perimeter of the rectangle. Do you see that? Now what I'm trying to show you is this is 5 2/3, and this right here is 5 2/3. Do you agree with me? So when I added those up, they were what? There was a total of 11 1/3, right? So now I had this much left. Do you agree? So if I do 23 1/2 minus 11 1/3, that's what's left. Do you agree with that? Yes. And I only want what? So I divided by 2. Yes, so listen to me, kiddo. If this side now is 6 1/12, this side is also what? 6 1/12. You hear me on that? Now, what I want everybody to do just to make sure it makes sense, Joseph, are you listening to me? All right, I want everybody to do on their calculator 5 2/3 plus 5 2/3 plus 6 1/12 plus 6 1/12. And what should that be? It should be 23 1/2 if you understand me. Well, try it again.
I got 20.
Bradley, I mean it with you. I'm not into your little funny games. Add. Everybody add 6 1/12, 6 1/12, 5 2/3, 5 2/3, and that should be what? 23 1/2. You understand me now? All right. Does anybody have any questions with the perimeter of a rectangle? That's actually a pretty hard problem because most people don't understand what the perimeter of a rectangle is. Joseph, are you with me? All right. Now let's talk about 21. Justice, let's have you read 21. Right. Tell me what you're thinking.
You are cutting fabric for placements that are to be 13 over 3/4 inches wide. If you have a piece of fabric that is 82.5 inches long, how many placements can you cut from the fabric?
What do I have to do you think?
Do you divide?
Exactly. Because why? If you're not sure, look. Here is fabric. Listen to me. I've got a long piece of fabric. All right? And fabric is generally as a what? Giant rectangle. And then what do you do to the pieces? You cut them, and then that'll be your what? That'll be your placemat. All right? So, for example, this I have 82.5, right? But I want to cut it so I get 13 3/4. Now that's a what? That's my first what? Placemat. Now I'm going to cut it right here. That's how much? 13 3/4. I'm going to cut it again, and that's what? 13 3/4. Now, what am I doing to the 82 1/2? I'm dividing it up. Now, if you're not paying attention, I'm not helping you with the hard word problems. And people are not good at word problems because they never think about it. Drawing pictures is the most important thing you can do. All right? And then once you draw it out and start saying, well, I cut it here, and I cut it here, and I cut it here, I'm doing what to the cloth? Dividing it. So that's how you know what to do. All right, so we are taking what? We are taking 82, thank you, Justice, and dividing it by 13 3/4. And what do I get, Justice?
You get 6.
Exactly?
Yeah.
Exactly 6. So you can cut out 6 placemats. That's it. That wasn't that bad. Bless you. All right, everybody good? What? You read the next one. Let's go. Come on.
The largest and smallest sea stars on the rectangle
Okay, now this one is a hard one for kids. This is a hard one. Very hard. So what am I going to do? Listen, because you're wanting to know how many times greater, to figure that out, you have to do what? Divide them. All right? That's a tricky one. Now, most people say what? Just multiply them because it says what? Because it says times. But you're trying to figure out how many times. So to work backwards, you have to what? You have to divide. You have to divide. Very nice. Very nice job on that, actually. So now, for this, you put down on your paper 37 4/5 divided by 7/10. And tell me what that worked out to be. 50 what? 54 times greater. Does it look 54 times greater? Do those numbers? It doesn't look that way to me. Right? If I was looking at 37 4/5 divided by 7/10, there's no way I'd say that's 54. Does everybody agree? That's why, listen to me, I want everybody to look up because I'm going to try to show you something how you can figure things out. Carter, I'm talking to you. Listen, I'm trying to make you smarter, so you got to pay attention. You hearing me? Joseph, you hearing me? Right. Now, sometimes these numbers are not easy to see. So what I do is I try to teach kids to do this. Put numbers in there that are reasonable. For example, let's say the large one was 10 inches and the small one was what? 2 inches. How many times bigger is it? That's obvious. Does everybody see what I'm saying? Now you have to say to your brain, how did I get 5 with 10 and 2? What did I do? I divided. So since I divided on the basic numbers, I'm going to divide on the complicated. That's what I'm trying to show you. Sometimes fractions look difficult because just the nature of looking at them looks tough. So if you learn to take the hard numbers and replace them with easy numbers, then your brain is easy to see. Well, that's obvious. I should just divide them. Because it doesn't look obvious right here to just divide those out. Lisa, are you understanding me?
Yeah.
You listening? All right, Ian, how about you, Ian? All right, listen, Bradley, let him alone. He can ask me if there's a problem. I want you focusing. All right, here we go. Good job. All right, let's take a look at 23. Mia, you're up. Read it.
You are given $35 to buy blue fabric to help make custom for school play. The fabric costs $6 per yard. Do you have enough money to buy 4.78 yards of blue fabric?
What do you think? There's several ways of doing this. What'd you multiply?
4.78 times 6.
Beautiful. Exactly correct. So 4 7/8 times 6. What is that? $29.25. So do you have enough money? Yes. What's another way we could have done it? You want to tell me what's another way?
You've done like 35.
Yes.
Could you have done like 35 divided by 4.78?
Well, I would have done 35 divided by 6.
I didn't do that.
Right? If you do 35 divided by 6, that'll tell you how much yards you can buy. Do you agree with me? All right, so there's two ways. I don't care how you're doing it. So, if you did a little differently, you just can tell me. And I can tell you if you're thinking good or not. That's a good way of doing it also, buddy. All right, that's why I fuss at you so much. You hear me? All right, that's good thinking. Very good thinking. Did everybody see what he did? He said, well, I'm just going to round this to 5 yards. And if I buy 5 yards, it's $30. So obviously that's a yes. That's very good, Brad. Does everybody hear me? Joseph, you picking up little tips, right? Pay attention. All right, here we go. Uh-oh. Let me have Thomas Dan. Tell me about 24. What's the formula for finding area of a rectangle? Exactly right. What'd you get? 17 3/5. Now, the only mistake you're making is if you don't put the units. You measure area with what, guys? You measure area with
inches squared.
squares. In this particular case, Justice, we're talking about inches squared. So I need you to write inches squared. You measure area with inches squared. Make sure that's on there. What? No. When you're measuring length, like if I say, how tall are you? You would say, I'm not square inches, right? I would just be inches or feet. So I should have come back here because I didn't. I should have said the perimeter. So it was 6 1/12 what? I should have put 6 1/12 what? Centimeters. Because it's a length. You understand me? A length is a single unit. Area is 2 units. Volume is 3 units. 2 units we say is square. 3 units is cubes. All right? But we're going to talk a lot about that this year. All right, so now I'm on number 25. All right, you want to give it a shot? Read it.
A recipe requires 2 1/2 teaspoons of baking powder, but the only measuring spoon you have holds 1/4 teaspoon. How many times do you need to fill this measurement? I did 2 1/2
2 1/2 divided by 1/4. Yes, that's exactly correct. You need 10, all right? You need 10 of the 1/4 teaspoons. All right, now let's talk about that. All right, you don't need 10 teaspoons, correct? You need 10 of the what? 1/4 of a teaspoon. Now, is everybody happy with that explanation? What? Yes, that's good. Perfect. That's exactly correct. Nobody has any questions? All right, let's move on. All right, boy, you can tell how old this is, right? CD, all right, and a cassette, all right, is really old. All right, really old. So you don't need to worry about it. All right. So it says a CD case is 3/8 of an inch wide, and a cassette case is 5/8 of an inch wide. If you want to put 8 cassettes on a shelf that is 20 inches wide, how many CDs? So here we go, guys. Look up at my great artwork. All right. First thing I'm doing is I'm building me a shelf. All right. I'm building me a shelf. And on my shelf, it's what? How wide is my shelf? 20 inches wide. So it's 20 inches wide. Are you with me on that? And now what I'm going to do is I'm going to put some cassettes. All right, so now watch how I put a cassette. All right, so I'm going to measure a cassette. And this right here is going to be my cassette. And I'm stacking it on my shelf. Does everybody see that? Everybody see that? Now, that represents 3/8 of an inch. Is everybody good? Now watch. So this is going to be my what? Second one. Everybody see that? All right, so I got to redo it again. Sorry, guys. So now what? Now I have how many? 4. How many do I need? I need 8. So I'm going to do it one more time. Just pay attention, please. I'm really trying to help you. And I think visualize. I'm trying to show you that you don't have to be great at this. And now I have how many cassette or how many CDs are there now? There are 8. And how wide is each one? How wide is each? Wait. If you want to put 8 cassettes, so each cassette is how much? 5/8. So this right here represents 5/8 of an inch. Do you agree with me? So now, how many inches have I taken up on the shelf? No, I don't think so. This is 5/8. This is 5/8. This is 5/8. Yes, come on, there you go. Now each one is 5/8 of an inch wide. How many did I put up there? 8. So how do I figure out how many inches wide is that? Multiply. Now look, you are not allowed to sit and just let me do the problems. You have to participate, which means get the calculator in your hand and do 5/8 times 8. That's what you're supposed to be doing. Not just watch me and go, wow, he's really good at that. Yeah, I know that. You are the one I'm trying to get good at. So how much is that? 5 inches. So if I lined 8 cassettes up, I would take up how many inches? 5 inches. So this distance from here to here represents 5 inches. Now, how much room do I have on my shelf? I have 15 inches left on my shelf. How do I know I have 15 inches left on my shelf? Because my shelf was what? And now I've used what? So I now have 15 inches left. I have 15 inches left. Am I clear on that? Clear. Clear. So now the question is, I'm going to put my what on the shelf? I'm going to put my CDs. But in this case, my CDs are only what? 3/8 of an inch wide. All right? So how many CDs can I fit on the rest of my shelf? How many? How did I do that? Shh, shh. Oh, I know what you meant, but you remember, are you dividing? Right, listen to me now. That's an important concept. I'm taking the 15 inches and I'm dividing it into what? 3/8 of an inch. Everybody hear me? Right? Shh, I don't want to hear what you said. What? Do you understand me? All right, are you doing that on your calculator? Are you doing the other part on the calculator? You're not getting smarter if you're watching me and just going, yeah, man, he's good at this. You got to be doing it. All right? So that was brilliant. 15 divided by 3/8. And we said that was how much again? 40. All right? So I can fit 40 what? I can fit 40 CDs on my shelf. All right, that was kind of hard. It was kind of hard. That's why I'm asking some of you. Now, some of you guys are not participating. You're really kind of bothering me. All right, I hope I made that clear. All right, I'm not doing this problem for me. I have given you calculators. We've given you iPads. I'm not asking you to draw. I'm actually to show you. I'm trying to show you visualizing is super important. Visualizing is important. Or it makes math much easier. All right? Any questions with why 40 CDs was there? All right, good, good, good. All right, who hasn't read today? 27. Who's up? I know you will. Good. Miss Connery, go. Thank you. 27. Okay, so this was kind of tricky now. What did you do? Okay, so now what I want to do is I want to watch. Again, here's how my brain operates. So here is 12 noon. And then this would be what? 1, 2, 3, 4, 5, 6. Come on, stay with me. Everybody. And then we go 7, 8, 9, 10, 11, and then 12. Do you agree with that? Now look, I think people are lazy if they don't get this correct. I think you're lazy. Right? Because I want you drawing it out. So everybody see those are the 12 hours, correct? Right? Now, the alarm goes off every what? 3/4 of an hour. And I mean this when I'm saying. Or I think you're lazy if you didn't get this right. So it goes off what? Once. You agree? So now that's at 12:45, right? And then if I go off again, it's going to be at what? Shh. What time is it going to go off? That's exactly right. 1:30. It's going to go off at 1:30. Do you agree with me? What's the matter? Well, it's 3/4 of an hour. 3/4 of an hour is how many minutes? 45 minutes, right? Now, again, you can say, that's okay. Let's look at the clock now. All right? Now, this represents 1/4. Do you agree? This represents 2/4. Do you agree? This represents 3/4. Do you agree? So this is 15 minutes. That's why when somebody says 1/4 of an hour, it means what? 15 minutes. You with me now? Because there are what? 60 minutes in an hour, and if I divide that by 4, that means there are 15 minutes in 1/4 of an hour. You with me now? So that's 1/4. Now watch how I'm trying to show you. That's 1/4, right? Now I'm at 2/4, right? Now I'm at what? 3/4, right? So that's 15 minutes, 30 minutes, 45 minutes, right? You with me or not? Remember what I told you. Don't. If it's not clear, don't. Oh, okay. So this is what I want to show you. 60 minutes. What that means is you're dividing up the hour by 4. So on your calculator, do 60 times 3/4. 60 times 3/4. That's what that means now. Do you agree with that now? All right, is that helpful? All right. So I have every 45 minutes the alarm goes off. Do you agree? So now we're doing it together. So we're at 1:30, and then it's going to go off at what? Yes, at 2:15 it's going to go off. Uh-oh, let me get my other one. So then it's going to go off what? 2:15. Shh, leave her alone. You're visualizing, guys. I mean this. If you're not sitting here doing the clock with me, you're making a huge mistake. All right, at 2:15 in 45 minutes is going to be what time? 2:15. 2:15 if I add 45 minutes. 3. And again, I know I'm putting you on the spot. I don't care. All right, stay with me. I'm at 3 o'clock. Then what? Then 3:45. Then what? Yes, 4:30. Then what? Good job, girl. 5:15. Then what? Good job. Then what? 6 what? We're at. Good job. 6:45. Then what? 7:30. Good. Keep thinking. 8:15. Then what? 9. Then what? Then what? 9:45. Good job, girl. 10:30. Then what? Good. Then we ended exactly what? Exactly 12. Right? So now let's count them. 1. Come on. 2. So it might be 16. I'm not sure. Okay, but How many more times will go off before 12, midnight? So it would be what? I tricked you on this problem. It would be how many? How many? 15. I tricked you on that problem. Right? Now, if you put 16, I'm totally happy with you. All right, totally happy. But I'm just showing you the details make important, right? That helps you. Now, listen, another way, instead of doing it by that way, hey, instead of doing that way, I could do what? Yes, very nice. Very nice, guys. 12 divided by 3/4, and what's that? That is 16. Now, the problem is it's going to end exactly at what? It's going to exactly at midnight, right? So you minus 1. If you're a thinker, you'd put 15. Right? That's what I want you to do. The details are important. Very good. All right, hopefully, now listen, that helps you with your clock now, understanding the clock a little bit better. All right. Now, this one's strictly a calculator problem. All right. So this means 3/4 divided by 8/3. That's all that means. And what is that? Is that right? 9/32? All right, so remember now, this is called a complex fraction. It's just a fraction divided by a fraction. All right, and we know how to do that. We just don't write it that way. So does everybody hear me now? You got to write that down now. 3/4, that's what that means. 3/4 divided by 8/3. Now, if you want to sound like you're good, you can say that's a complex fraction. All right, that would be a nice thing to put in your notes. That's called a complex fraction. When you put a fraction with another fraction, it's called complex. All right, now look, guys, I'm really thinking you should be mirroring what I'm doing up here. All right. Now I know some of you can't draw as well as I do. I understand that. All right, 29. Here we go. It says you set up an inline skating course 21 feet long. So here's my 21 feet, guys. Here to here is 21 feet. Right? And you're going to practice weaving around cones. You want to set up a cone every 3.5 feet, but not at the start or the end. How many cones will you need? Tell me.
So I did 21 divided by 3.5.
And what'd you get?
6, and then you subtract 2 because they don't want to be done.
Wow, smarty pants over here. All right, let's see if he's correct. Now, again, in your mind, here's what you should be saying. There's my 21 feet. Does a cone go in the first step? No. So now I'm going to measure out what? I'm going to measure out 3.5 feet, and then I'm going to put a what? I'm going to put a cone down. Everybody with me? And then I'm going to measure out another what? 3.5 feet, which is going to take me to the what foot mark? What? Does everybody understand him? Does everybody understand? I'm at 7 feet now, right? So at 7 feet, I'm going to require another cone. And then what? 10 and? Thank you. Come on, everybody give it a shot. 10.5 feet. I'm going to require another cone. And then at the next mark, what's the next mark going to be? At 14, thank you. At 14, I'm going to require another cone. And then what's the next one? Harmon Joe. Let her think. And 17.5. You understand why it's a half, right? 17.5. So here we go. 17.5. And are we done? Wait a minute. I'm not asking you about the answer. I'm saying, do I count out another? If I count out another 3.5 feet, I'm where? I'm at the what? I'm at the end of my course. Do I put a cone? Do I put a cone? No. So what's my answer? What's my answer? What's my answer? Are you looking? How many cones did I put? I put 5. All right. So there are 5 cones. Now listen to me. That's a very good, tricky question. That's what I'm trying to show you guys if you draw this out, I'm right. I'm going to be right. All right? I'm not expecting you guys just to say, hey, this is what the answer is. You got to put some thought into these problems here. Does everybody understand what I'm saying? It's not that hard to draw a cone. Come on now. It's not that hard to draw up 21 feet and then count out every 3.5 feet just to make sure you're correct. Right? Because it seemed like the answer should have been what? It seemed like the answer should have been 4. All right? It seemed like the answer should have been 4. All right? But it's not. Instead of it being 1, 2, 3, 4, 5, 6, 7, you hear me? Listen to me. The reason why it's 7 and not 6 is because if we were to count, I start at what? 0. There's a mark at 0. And then what? 1, 2, 3, 4, 5. You with me now, right? All right. Everybody happy with this?
Yes.
Let's see what the next one is. 30. All right. Here we go. Man, this is a fantastic problem. Who hasn't said anything today? Come on. Have you said anything today? Thank you. Go. Read.
A ball dropped from a height of 6 feet begins bouncing. The height of each bounce is 3/4 of the height of the previous bounce. When the ball mounts to a height less than half of the initial height.
Okay, so look, guys. Everybody can draw a bouncing ball. All right, come on. Now look, seriously. Look, guys, especially with your iPads. Look how fun this is. All right, here's my ball that's going to be dropping off the wall. All right, so I've got a wall over here, right? And my wall is how tall? My wall is what? 6 feet. So I take the ball right here. Listen to me now. I'm taking the ball that I'm getting ready to drop, all right, and it's 6 feet off the ground. Everybody can do that. Now I take the ball and, take the ball, it hits the ground, and then it bounces up. All right, so how high is it now? How high is it? Ian, are you listening? I don't think you are. How? 3/4 of what? 3/4 of 6 feet. Beautiful. Now, how do you do 3/4 of 6? What does of in math mean? Multiply. So everybody do on their calculator 6 times 3/4.
I got 4.5.
So now the ball is what? 4.5 feet high. All right. So now the ball does what? Turns around, bounces again. All right. Now, hold on a second. Multiply it again by what, please? Wait a minute. What are you saying 2/4 for? What are you saying 2/4 for? It went down to 4.5 feet. It bounced, came up to 4.5 feet. So now what am I going to do?
4.5 times 3/4.
4.5 times 3/4. Because each time it bounces, it's going to come up 3/4 of its original height. So,
And then it's
what is that?
3 feet. And then
Is it, whoa. Would you do 4.5 times 3/4, please? Everybody's supposed to be doing this. 4.5 times 3/4. What is that? Shh, I'm asking. 3 3/8. That's not what you said. So the ball bounces, and it comes up to 3 3/8. We're not going anywhere. Now, is it less than half of what it started? No, not yet, because half of it have to be what? It have to be under 3. So now I take 3 3/8 now, and the ball goes and hits the ground again. How much should it come up? Everybody's supposed to be doing it.
So you would just do 3 and 3 times 3 and 4.
2 and what?
7.
Is it less than
Yeah.
halfway? Right. So what's the question? Right, so it's going to be, now let's pretend, boom, there's 1 bounce, 2 bounce, 3 bounce. On the 3rd bounce, right, it'll be less than 3 feet off the ground. Does everybody agree with that? Now I'm just trying to show you how you draw things out, guys. Draw things out, it's good, it's healthy, it's good for your mind to see what you're doing. All right, your homework is to finish it up. The homework is to finish up the worksheet. All right, get on it, guys. That was a good day today. Very good for those of you guys who participated and tried to draw as good as I do. You can start somewhere now. Doesn't have to be that good, but you can start somewhere.